At its foundation, the ICC leverages blockchain technology to enable seamless, transparent transfers of digital assets between different legal jurisdictions. Consider these groundbreaking capabilities. Secure escrow functionality allowing clients to deposit case retainers and other digital assets into reputable third-party custody. Automated transfer of pre-agreed portions of deposited assets to counterparties when certain computable conditions are fulfilled. Immutable transaction histories providing undisputed evidentiary records acceptable to any court. Integration of oracular services to query off-chain legal databases and apply relevant precedents within the smart contract logic. Interoperability with other blockchain networks through cross-chain communication protocols. With these tools, we can programmatically enforce contractual agreements, leverage big data insights, and reduce disputes all on a neutral, tamper-proof infrastructure. The game-changing legal implications are clear. This evolving narrative of the ICC smart contract focuses on utilizing Chainlink CCIP for cross-chain messaging and using Chainlink node operators to query off-chain data through API calls. Here's a breakdown of the files necessary to be used with the ICC smart contract and legal application. 1. Secure cross-chain transfer and Lex Oracle smart contract. Written in Solidity, this smart contract handles the interaction with Chainlink. It defines functions for initiating Chainlink requests, processing responses, and implementing the logic specific to the legal tech application. External adapter, the secure cross-chain transfer and Lex Oracle JavaScript file. Written in JavaScript, this file serves as an external adapter to interact with the API. It fetches data from the external source like the case law API and can perform any necessary data transformation before passing it back to the smart contract. 3. Deployment scripts, the deploy smart contract JavaScript file and the deploy Chainlink job JavaScript file. These scripts handle the deployment of the smart contract and, if needed, the Chainlink job. The job specification JSON file, written in JSON. This file specifies the job that Chainlink nodes will perform. It includes information such as the type of initiator, task to be performed, and any necessary parameters. This configuration is essential for telling Chainlink nodes how to interact with the external data source. While the smart contract is written in Solidity, the interaction with Chainlink involves external components like the external adapter and Chainlink job specification, which is written in JavaScript and JSON, respectively. These files work together to create a decentralized Oracle system, with the smart contract as the core component handling interactions with both the blockchain and external data sources through Chainlink. At its core, the secure cross-chain transfer and Lex Oracle facilitates cross-chain transactions between different blockchain networks like Ethereum, Polygon, and Avalanche. Users can deposit tokens into the smart contract, which are then securely held until the owner triggers a cross-chain transfer to the next specified network. Chainlink oracles handle retrieving any necessary data from off-chain sources and enabling the actual transfer of funds across chains. The smart contract tracks user balances, token approvals, transaction histories, and messages associated with addresses. Importantly, sensitive data like API keys are stored encrypted on-chain, only accessible to the smart contract owner. The owner can set a decryption key to securely reveal the plaintext data when needed. Now, allow me to walk through some specific examples of how the ICC smart contract could be applied. In practice, the ICC represents the secure logic controlling asset transfers on the smart contract. The different legal realms symbolize individual blockchain networks like Bitcoin or Ethereum which have distinct protocols and jurisdictions. Its arsenal includes a set of functions meticulously crafted to handle both the intricacies of cross-chain messaging and the retrieval of off-chain data through Chainlink node operators. Its primary purpose is clear: to facilitate communication and data transfer between blockchains, transcending the limitations that confine assets and information to their respective chains. In the grand tapestry of the ICC's narrative, legal professionals find echoes of their familiar processes. Smart contracts, much like legal agreements, are executed with precision and transparency. The smart contract's primary objective is to enable users to securely transfer tokens across different blockchains and obtain legal data through Chainlink oracles. It achieves this by integrating Chainlink oracles, utilizing the Chainlink Interoperability Protocol, CCIP, and implementing secure cross-chain transfers. The smart contract is deployed on Ethereum but supports interoperability with other chains such as Polygon and Avalanche. Creating a smart contract involves programming on a specific blockchain platform, such as Ethereum. However, there are some challenges with creating a smart contract that handles off-chain data. Smart contracts on blockchain networks, like Ethereum, are executed in a secure and deterministic environment. They can't directly interact with external web resources or APIs that require authentication, such as a county recorder website. Given these limitations, the general idea is to have an off-chain service, like a Chainlink oracle, that interacts with the external API and then provides the data to the smart contract. The smart contract then interacts with the oracle to receive the data. The Chainlink client contract and the corresponding functions we used as a basis of this project are part of the Chainlink framework. ICC smart contract presented here assumes that the external API returns the required property data as a string, and it emits an event with the result when the data is received. A front-end application, HTML/JavaScript, was developed to interact with this contract and display the results in an index HTML file. When interacting with Chainlink, the ICC smart contract serves as the interface between our decentralized application and the Chainlink network. The ICC smart contract contains the logic for initiating requests to external data sources, such as the case law API, and processing the responses.